Hi students, welcome. So in this lecture we will discuss about the vectors. In the series of lectures we will discuss completely vectors. Okay, so let's first define what is vector. Let's understand that. So I'm taking just a few examples for that. So let's say if we take mass, one quantity mass, and another quantity the force. So now, if I want to define the mass, I will just need the magnitude and its unit, right? So like if this is the box, so I will say that the, let's say, mass is 5 kg. So this is 5 kg. Similarly, if I'm applying a force, let's say a force of 5 Newton on this box like this, so 5 Newton force I'm applying, right? Now see, if I define the mass, this 5 kg is complete definition for the mass. Okay, there is no need for any extra information. But if I say that 5 Newton force is acting, that is not sufficient. You will also need the direction to define it completely, right? You will need the direction. So that's why on this basis we can say quantities, physical quantities can be of two types. So I can say that physical quantities can be of two types, primarily two types. One are those quantities that will just have the magnitude. Okay, they will have magnitude. And another type of quantity which will have magnitude and its direction. Okay, another type of quantities are there which will have magnitude and its direction. Okay, so those quantities which only have the magnitude are considered as or they are called as the scalar quantities. Scalar quantities. So like for example mass. So for the mass you will need only the magnitude to completely define it. Okay, so and there are the other quantities which will need the magnitude as well the direction. Okay, there is one more condition for the for quantities to be vector. Okay, so that is they should follow the triangle law of vector addition, but that we will understand. Okay, so scalar quantities are those quantities which only have only magnitude, right? And the vector quantities are those quantities which have magnitude plus direction, and they also follow the triangle law of vector addition. Now what is triangle law, that we will understand. So they also follow the triangle law of vector addition. Okay, so they follow the triangle law of vector addition. So these are three conditions to be a vector, to call something as vector. First, there should be magnitude, there should be direction, and that should follow the triangle of vector addition. So like if I take some example for the scalar, so scalar example are like mass. Okay, the example are mass. Okay, think about some example. Okay, time, can we consider time as scalar? Yes, we can consider. Okay, similarly we can consider length as the scalar. Okay, energy as scalar, and then the distance, speed. Okay, there are many other quantities. So in case of vector quantities, the examples are which should have the direction. So like force, displacement. Okay, I think you know the difference between the displacement and distance, right? And velocity, because the velocity will also have some direction. Then momentum, mass multiplied by velocity, because velocity is a vector quantity, so that's why momentum is also a vector quantity. And there are similarly other examples of the vectors. So these are the vector quantities. Now there are some exception, like the quantities are there, the direction is there, but they do not follow the triangle of vector addition. These type of quantities are considered as the tensor quantities. So I'm explaining one more type. So these are two primary types of the physical quantity, but still we can divide physical quantities in one more type, that is known as tensor quantity, tensor quantities. So right now there will not be much use of these one tensor quantities, but we will primarily focus on the when we will study, so we will focus on the scalar quantities and vector quantities. Okay, so tensor quantities are those quantities which have the magnitude and direction. They have the magnitude and direction. So they have magnitude and direction, but they do not follow the vector triangle of vector addition. Don't follow vector law of addition. Okay, fine. So now what are the example for this one? The example are the electric current. We can take electric current. So see, electric current will have some direction, like if this is some junction, okay, and a current is coming from this direction, 3 ampere, 1 ampere, so this will be 4 ampere, right? If I change the angle between the 3 ampere 1 ampere, then also this will remain same, okay, but if I reverse the direction of 1 ampere, so then this will become 2 ampere, right? So from here just we can understand that by changing the angle between these two currents, the effective current is not changing, and triangle law of vector addition, when we use this, angle is also important. It means from here we can understand that this electric current is not following the triangle law of vector addition. So that's why electric current also have the direction, okay, but it is considered as tensor quantity because it do not follow the vector law of addition. Okay, so this is about the vector quantity.